Today is day 2 of the midterm review. Today we'll be going over linear key features, our slope/rate of change, and writing linear equations. One of the first things we want to go over, and we really want to just get the concept down, are what the actual key features of what linear equations are. Some things that we will have is our x-intercept and y-intercept, which are referring to where they cross the respective axis. So when we say x-intercept, we're referring to when it crosses the x-axis. Now, when we're referring to the x-axis, that is the first number that we would have in an ordered pair. As you can see up here, we have two ordered pairs. They will always be listed as the x value first, followed by the y value. It keeps consistency throughout everyone who is dealing with the coordinate plane so that everyone understands what they were referring to, what order we were discussing. So in this case, this one crosses at a x value of -4. The location of this x-intercept is -4, 0. We take locations, we take points, we take the ordered pairs, and the way we show them is by having them inside parentheses and separated by a comma. So we understand that the left side of the comma is our x value and the right side is our y value. So we don't get any confusion. Our y-intercept is where it crosses the y-axis. And same situation, we refer to the y as the second number, this crossing the y value of -3. So we have a location of 0, -3. Now following the ordered pair, we always want to go in the direction of our x value first. So we use our x number line to find the first numbers. So in this case, we had to go to -4. For this one, we did not go left or right. We stayed at an x value of 0. And then we go up and down. For our y-intercept, we had to go down -3. Whereas for the x-intercept, we didn't go up or down any value. We stayed on the x-axis. Slope and rate of change are interchangeable. They refer to the same thing. And what they mean is the change in our x values and our change in our y values. So it does not matter what points you pick of the line. Whenever you are doing this, we do our rate of change. It goes top number is down or up. And then our second number in our fraction, which sets up our slope, goes left or right. Now, in normal cases, when dealing with slope, you always want to start from your left point so that the only value that will be negative is your top number, which is your change in y. So this will be our slope / rate of change. And for this one, if we look closely at the 2 points they picked, we would go down 1, 2, 3, and then over 4 to get onto the same line. So always remember that your top number is how much up or down you go, and then your second number is how far right you should be going, because you should always start from the left point and go to the right. This keeps consistency down so you do not make a mistake, which happens quite a bit. Can you go the other way? Yes, but you have to be careful. You lose that consistency. Our rate of change being the -3 over the 4. So in this case, we discussed our x-intercept, we discussed our y-intercept, and our slope, aka our rate of change, all being one thing. The last piece is our 0, and this is connected to our x-intercept. Our 0 is just referring to the x value of our x-intercept. So with that, our x-intercept is also dealing with our 0. I think I can zoom in a little bit. There we go. Now, using some of that information, question number 1 says, what is the 0 of f of x equals 8/3 x minus 16? If we look back up to what 0 actually is, that is when our y value is 0. So when we have an equation like this, you could type this in the calculator and try to find where your y value is 0. The other test tip that you could have is plug in each one of these numbers for our x value, x variable, and see which one would come out to be 0. Whichever one makes the expression 0. The last way, using mathematics, we would take our equation and we saying that our f of x is actually 0. So in this case, we can say 0 equals, let's turn this into an entire equation so it looks the same. Zero equals 8/3 x minus 16. Our next step would be add 16 to both sides. Yet again, probably want to keep this as a equation format. The way I personally like to do is eliminate our denominators, the bottom of the fraction, by multiplying everything by that bottom value. So I'm going to multiply everything by 3. This will leave the top number, which is still multiplied to my x variable, and then I can just divide. Divide both sides by 8, which will give me 6 equals x, or in other words, our 0, x, is 6. So this is how to show it through algebraic reasoning. Number 2 says the graph below shows the relationship between the number of gallons of fuel remaining in the truck and the number of hours the truck has been driven. It asks, what is the x-intercept of the truck and what does it represent? So we are looking for the x-intercept and what does it represent? What does our x-intercept in this equation mean? So understanding x-intercept is when it crosses the x-axis. It brings us over here. Now we need to remember we always have an ordered pair of x value first, then we follow up with our y value. So this would be the 20 as our x value, and we didn't go up any, so a 0 for my y value. Those don't deal with the correct numbers. Now we have a choice between G and J. So now we need to understand what it represents. If we look at this x-axis, it counts by twos and it's talking about times driven. So as we move farther to the right, this is representing more hours of driving the truck. If we look at the left, our y-axis, this is talking about fuels in terms of gallon, and we start at 200. And as time goes on, as we go to the right, we start going lower and lower on our y-axis, which makes sense. We are showing that we are using gas. We are losing gas. So when we look at our example, it says the number of hours the truck has driven before running out of fuel, which would make sense. We drive the truck for 20 hours and then we make it down to 0. Or the numbers of hours required to use 1 gallon of fuel. Well, in that case, that would be the rate of change or the slope. So in this case, our best fit is the number of hours the truck was driven before running out of fuel. We ended up at 0 gallons at 20 hours. Number 3 asks, what is the y-intercept of the line graphed on the grid? So in this case, we're looking at the y-intercept. That's when it crosses our y-axis. And in this case, our line doesn't cross exactly at a whole number for my y. So there's multiple ways to go about this. One way is to create an equation and then plug it into a calculator. Another one, we can find our slope. Now the slope formula, if I get to the right part, our slope formula is m equals, lowercase m, equals our change in y over our change in x. So they give us 2 points already, so we can use those to help us out. If I look at my change in y, this is going downwards from the left point to the right, and I go down a total of 6 units. So I know that my slope, my m, is equal to my top value is 6, and it's going to be negative. Now we can use this line to go over, which would be our change in our x value. We can count these all up. We can subtract 6, or subtract negative 2 from 6, which give us a distance of 8. So with this, we can simplify this to help us out to make it even easier. They both can be reduced by a factor of 2. Which would give us 3 over 4. Now this makes sense. If I use this point, I could go down a total of 3 and then go over 4 and still be on the line. I can use this idea to half each number. That'll give us going down 1.5 and then going over 2, which would get on the line. So I knew that I went down 1.5, which would put me at 5.5, which would be my answer. Now to use algebraic reasoning, I need to remember the equations that I was given. The best one for this situation, now that I found slope, would be the point-slope formula. The point-slope formula being our y minus our y1 equals our slope multiplied by x minus our x1. Now to recap what this means, let me put this to where it's not right over. Our y1 and our x1 is referring to our first point. It's referring to an actual value where our regular x, y are the values of the number line, depending on where I'm at. If I fill this out with one of the points, the 6, 1 that I can see, and the slope that I found that was negative 3/4, you would get y minus 1 equals the slope, which was negative 3/4, minus my 6. Oh, what am I doing? I need the parentheses here. Slope times x minus 6. Now, since we're looking for the y-intercept, if we go back up here, we can see that a y-intercept is when our x value is 0. So I can actually rewrite this knowing that I need my x value to be 0. Now I can solve for y. Oops, did not mean to double. There we go. Knowing that this was 0, this leaves me with a negative 6. Getting rid of the parentheses, we would do the negative 3/4 times the negative 6 which would leave us with the 4.5. Had to make sure I did the math right. Didn't want to make a little mistake with fractions. Notice that it's positive because we multiplied a negative by a negative. And then we would need to add 1 to both sides. Adding 1 to the left side cancels out the negative 1. 1 plus 4.5 becomes 5.5. And that matches up with my answer. So that's how I check it algebraically. It does take a little bit more time, but it makes sure that you have the correct value. You cannot always just use an eyeball to gauge it. I'm sorry, the phrase is you can't eyeball it to gauge what the actual value is always. Other formulas that you can use is the idea of when you are looking for which equation, which graph represents a given equation. Notice that all these lines cross through the x and y axis. So I can use the x and y intercept to help me out. If I'm looking for the x-intercept, that is when my y value, if I can type it right, my y value is 0. So if I were to solve this out, I would have 4x equals 20, because 5 times 0 is 0. And then I would divide by 4, which would give me the x equals 5. So with this, I can see that I replace my y. My x-intercept would be 5, 0. So I already have one of mine. I can check to see which one of these go through 5, 0. Our first one goes through negative 5. So that doesn't work. C goes through 1. That doesn't work. B goes through a value between 2 and 3. That does not work. And D does. So in this case, I don't have to go any farther. All of my other options were eliminated, so I'm only left with D. I could do the same thing plugging in my x value of 0 for my y-intercept to find that my y-intercept value should be 4. So we would go up. We can tell that it crosses through 4. So that's if you need to continue on. Speaking of which, we'll go on to the next section of focusing on slope and rate of change. Now, I can interchange these phrases whenever I like because they mean the same thing. When finding a slope or the rate of change for a table, you can compare any 2 points and use their change of their values. My change in y goes from negative 1 to 1. That is a change of 2. My x change is from negative 2 to negative 1. That only changes a value of positive 1. Now we always want to have our change in y, this is delta y, over our change in x, delta x. For this problem, that would be 2 over 1, which we can simplify to a whole number of 2. So in this case, my slope, my rate of change, is 2. When given a set of points, we can use the slope formula. With this, we need to know what our x and y values are. Now in this case, there is no difference right now between my variable x and my variable y. They look the same. What we do then is label each one with a subscript. Subscript is a smaller number. At the bottom, now I can identify the difference between my first point and my second point, which will help us out in the equation. Of m equals my x2, oh, hold on, gotta get this set up right. There we go. X2, nope, that's still a subscript. There we go. Minus, ooh, it's a little tedious right now. X1. Oh, I even used the wrong variable. We have the change of y on top. Making all types of mistakes, guys. At the bottom, we have x2 minus our x1. Now that I'm done playing with all that, which made it really difficult, make this a little bit larger for everyone to see. We have our slope is equal to y2, in this case will be our 12, minus y1, which will be our 7, over x2, negative 39, minus our x1, 26. So to clean this up a little bit more, by showing our values in the equation, we have the y2, like I said, was 12, minus my y1 of 7 over my negative 39, x2, minus 26, my x1. Now at this point, you could plug this directly into the calculator if you wanted to do all the steps. Oops, I didn't move all the way over. There we go. 12 minus 7 is 5. And negative 39 minus 26 is a negative 65. Now we can reduce this. If you have a calculator, it will do it for you. All you have to do is click Math, Enter, Enter to reduce the fraction. We see that both of them end in 5. That means they can be reduced by a factor of 5, which will give us negative 1 over 13. So if we look at our problems, we can find that we have a negative 1 over 13. B and D would be as if you made a mistake by not reducing both the top and bottom. And then C would be as if you flip the numbers around. If you put your change in X above your change in Y, which I almost did at the beginning of that. Problem 7. It goes, the graph shows a linear relationship between the amount of water in gallons in the tank in respect to the number of minutes it has been draining. So in this case, draining is a sense of it going downwards. And as time goes on, we lose water. We get less and less water. It subtracts. So this asks, which of the following best represents the rate of change of the amount of water with respect to the number of minutes that has passed? So when you have a problem like this, you can choose any 2 points. I'm going to choose the last two as they choose the smallest numbers of y. And I can see their change. I can describe their change. Remembering that I'm going to have the change in my y over my change in my x. Now for this, we go down one line, which unit-wise is down 50. So you need to be careful with what your lines are counting by. They don't always count by ones in both directions. Now this shift over one line for my change in x is actually a value of 1. I went from 8 to 9. So now I have negative 50 over 1, which is just negative 50. I look at my answers. I have B, D and B, said that backwards. B and D are if I had the fraction flipped upside down, I might make a mistake there. And then A and B are if I forgot that this line is going down before it goes over. The negative is key. Now when we're writing an equation, when given a table, we can use the point slope form in this case. Right now we don't have the y-intercept. We do not have an x value of 0, so I can't use that form directly. But I can use the point slope form as it is very simple to find the slope. My y change is going down 2 whenever my x change is going up 4, which gives me 2 over 4. I'm sorry, that'll be negative 2 over 4, which is simplified to be negative 1/2. And this is referring to my slope. Now if I scroll back up, I can take a shortcut, as I already wrote down the formula for point slope. Now to help us out, I can choose a y value that would give me a positive 1 or a positive 2 in the equation, which would be the opposite. So in this case, I would be looking for a negative 1 or negative 2 for my y value, which I have one. I have the negative 2 right here. So if I plug that in, that would give me y plus 2, not supposed to be capitalized. This would give me x minus 2 there we go, x minus 2. And my slope in this case was the negative 1/2. But if we look at our answer choices, they are in decimals, except for our last one. So we want to change this to a decimal, which was negative 0.5. I'll put the 0 there to match it up even more. Now in this case, My point slope formula does not match up yet. If I get rid of the parentheses, just to get it closer to what it needs to look like, that would give me negative 0.5x, and negative 0.5 times a negative 1 gives me a positive 1. So if we continue, because we still haven't matched up fully yet, this side does not have a 1, so I can subtract 1 to help out to match up. If I were to subtract 1 to both sides, which I need to get that figured out, subtracting 1 from both sides will give me y plus 1 equals negative 0.5x. So in this case, even though I started off with the plus 2 and this looked like a good answer choice, when doing the work, I realized that I still need to move that plus 1 over to get my actual answer, F. Now, another way to do this on the calculator is simply solve for y on each one of these, and then plug it into the calculator and see which one gives you the table values that you have shown. So that requires you breaking down each one of your answer choices. The actual way does require some bit of critical thinking in order to find your answer with the slight change. The graph of the linear function is shown on the grid. It wants us to find which equation matches up with our line. Now, just looking at our point slope formula, we'll copy it down for reference. Since all of these are in this setup, we can check. For A, it says that we have a y of negative 7, and we have an x of a positive 4. 1, 2, 3, 4. So this one's point lands on the line. We can continue to check the rest of them to see if we eliminate any options. This one says y value of negative 1, x value of negative 2. So we can go down 1, and it says negative 2. That one does not land on the line, so I know that's not the answer. This one has an x value of negative 7 and a y value of 4. Notice that I am saying the opposite of what is shown. That's because the equation has the opposite. This has in a blank space, so I know that's not it. My last one gives me an x value of 1 and a y value of 2. So using just the point alone, I found out that I can eliminate 2 options. From here, I can use the slope. If I use this point for my last one, it says I need to go up 3 and over 1, and I should still be on the line, which is not the case. If I check my other one, it says go down 3 and over 1. I am exactly where the arrow is pointing. So this is breaking down the formula of the point and using the slope to help the last part out. the last and final problem for this video. If y'all are still watching this videos, kudos to y'all. Y'all almost done. It says the researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier had a thickness of approximately 450 meters when it was first discovered. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day. Which function can be used to find the thickness of the ice shelf in meters X days since the discovery? So we want to know which function will help us find the thickness in meters X days since discovery. So now this is understanding how the verbal description sets up with our key features. If we look back at our problem, it says 450 meters when it was first discovered. This is letting us know that that is our y-intercept. Whenever it's the start, the beginning, any term that refers to that, that is letting us know on a graph that would be the very beginning. Our x value is 0. It says that the ice shelf is decreasing. That means I'm going to subtract at an average rate. This is a part of our phrase rate of change of 0.06. So now I know that it's going to decrease. It's going to subtract 0.06 meters per day. Another key phrase is our per day portion. So if I set this up into slope-intercept form, I'm saying that my function y equals our slope, in this case, which is negative 0.06 per day, so I don't know how many days, x. When it starts, our y-intercept value of 450. Now, if we look at our answer choices, they do not have it in the same order like I do. But this one is still referring to the same value. You have commutative property. You can switch full terms around as long as you keep the symbol in the correct place. I would have to distribute, which would change my 450. This one shows that my slope is positive, which it is negative. And yet again, this one I would have to distribute, which would change my 450. So I'm left with A. Now, I apologize for this being a longer video. These reviews are specifically for my classes, covering all of the information that we had from Unit 1 all the way to Unit 5. So if you stuck around this long, thank you very much. You can watch any of my other videos from there to help you out. Y'all have a good day.